Good morning. Today's topic is single phase induction motor. In the last lecture, we have discussed about three phase induction motors. We have seen the operating principle, the important components of three phase induction motor, and we have also seen that three phase induction motors are self-starting because of the rotating magnetic fields. Because a three-phase supply can develop a rotating magnetic fields, and because of this rotating magnetic fields, the three-phase induction motors are self-starting. And we have seen that the induction motors, they never run at synchronous speed, and the difference between the speed of the rotating magnetic field, which we call it as synchronous speed, and the speed of the rotor. The difference between these two is called as slip speed. This is ns, so ns minus rotor speed. This is called as the slip speeds. And we have seen that there are two types of three-phase induction motors depending upon the rotor, and they are squirrel cage induction motor and slip ring induction motor. We have seen the constructional differences between these two, and we have also done some numerical problems on synchronous speeds and calculation of slip. And we have also seen the applications of squirrel cage induction motor and slip ring induction motor. In today's class, we will go with single phase induction motors, the widely used motors in industry. The single phase induction motor, exclusively used for our domestic applications, because we will be getting single phase supply in our domestic, in our homes. So that's why we will be using single phase induction motors. You can find so many applications. You take the ceiling fan, you take your cooler, everywhere you can find single phase induction motor. So today's class, we will see the construction, the principle of operation, and the applications of single phase induction motor. I hope that by the end of today's lecture, you will be able to describe the construction, principle of operation, and also list the applications of single phase induction motor. So I'll start with why single phase induction motors. Because even though three phase systems, the electrical generation is done in three phase, even though transmission is done in three phase, even though distribution is in three phase, but single phase power systems are more widely used. All domestic, and you take agricultural applications and commercial applications, we generally use single phase power systems. We rarely use three phase power systems in domestic usages. They are mostly confined to industrial applications. In single phase system, why we do prefer single phase system is that it is a little bit more economical at our domestic applications. And in particular, as already said when we have been discussing about three phase systems, we have said that three phase power systems, they offer us more amount of power. But whereas in domestic and commercial applications, we may not need that much amount of power. So we confine ourselves only to single phase systems. So as mentioned here, they are used more widely than three phase system for domestic purposes, commercial purposes, and also to some extent industrial, small scale industries also. They will employ single phase power systems because it is more economical when compared to a three phase system, and the power requirement in most of the domestic, commercial, and small industrial applications, it can be easily met with a single phase system. And single phase system is very simple in construction, cheap in cost, reliable, and easy to repair and maintain. This is the biggest advantage. Because of all these advantages, we are using single phase power systems, and in particular the single phase induction motors when compared to the three phase induction motors, because of their simplicity in construction, because of their cost effectiveness, they are being used in domestic applications. You can find them in vacuum cleaners, fans, washing machines, pumps, blowers, etc. Sorry, it is repeated. So all these things we are employing single phase induction motors. There are so many types of induction motors, single phase induction motors. All these are being employed in all domestic and commercial applications. We will see now today the basic components, the basic principle of single phase induction motor. I won't jump into detailed classification, just I'll give an overall brief overview how it works, single phase induction motor. So coming to the components, a single phase induction motor, which we call it as an asynchronous motor, just like your three phase induction motor. It has two main parts, namely rotor and stator. Stator, as its name indicates, it is a stationary part of the induction motor. A single phase AC supply is given to a single phase induction motor. It will be just like this is your stator, and internally you will be having a rotor to which there will be a shaft and it will be rotating. Whereas this will be fixed with some bolts and nuts. This is called as a stator, which is generally fixed, whereas this is a rotor. So the rotor is a rotating part of the induction motor. Here it connects a mechanical load with the help of a shaft. Normally in single phase induction motors we do find squirrel cage rotor types. Okay. Now the construction point of view, it is very similar to that of squirrel cage three phase induction motor, but normally in three phase induction motor we have seen that the stator will be having three phase windings, but whereas in single phase induction motor generally we will be having two windings. Even though it is a single phase, we will try to make it as two windings. Why we do need two windings, that we will see in our next slides. So this is a picture of a single phase AC supply. Okay, I'll agree that it is a little dim. It was taken from the internet. See, this is your stator winding. It will be wound, and in that one there will be a set of poles, and this is your supply which you are providing. Okay, and this is your rotor, and here you will be having a shaft to which you will be connecting your mechanical. Okay, so this is your squirrel cage rotor, and this is your shaft to which your mechanical loading will be done, and this is your stator winding to which single phase AC supply will be given. Now, as already said, we have seen it in three phase induction motor. For working of an electrical motor, we do require two fluxes, right? Whether it is AC or DC, we require two fluxes. Interaction of these two fluxes only will give you the required torque. So when you provide single phase AC supply to the stator winding of single phase induction motor, now you are getting only one flux, right? So your stator winding will be getting only one flux. So your stator is being given a single phase AC supply. So you will be getting only one flux, one AC flux, right? And this AC current, it produces an alternating flux, which we call it as a main flux. Now this main flux, what happens is, your rotor is there, right? This is your rotor. So this main flux, it links with the rotor conductors and it cuts the rotor conductors. So defaultly what you do expect, you will be expecting that there will be an EMF will be induced in that one. Yes, EMF will be induced. Now the rotor circuit, because it is of a squirrel cage type, it is a closed one. So the current starts flowing in the rotor and we call it as a rotor current. And this will produce a rotor flux. Okay, so what you are doing, it is just like you are providing supply and so automatically I is flowing, and this will develop a magnetic flux here, and because of this flux, since this rotor, there will be a current because it is being short circuited. Okay, that's why it is called as an induction motor. Now there are two fluxes, one is a main flux, the other one is a rotor flux, right? These two will provide you the desired torque which is required for the motor. Okay, now this is a picture of this is your capacitor start and run induction motor, a type of induction motor. I'll come back to you this figure later on. Now, but the biggest problem with the single phase induction motor is that it is not a self-starting motor. Why it is not self-starting? There is a theory which has been proposed by the engineers that, according to that theory, is named as a double field revolving theory. Try to remember double field revolving theory. According to the double field revolving theory, any alternating quantity can be resolved into two components, right? You will be having a positive cycle and you will be having a negative cycle. So these two cycles now, they are responsible for developing of two fluxes which rotate in opposite direction to each other. So you take an AC flux phi. The field at the double field revolving theory states that it consists of two components, phi m by 2 and minus phi m by 2, which rotate in opposite direction. One half will be rotating in this direction. The flux which is developed here, it will be rotating, one half will be rotating in this direction, the other half will be rotating in this direction. As a result, both of them, they cancel out each other. So the net flux will rotate in the both. So we'll call these two components of flux, one which is moving in the positive, one which is moving in the forward direction. We call it as forwarding components. This is called as a forwarding components. The other one we call it as backward components. Okay, which is moving in opposite direction. Okay, so the resultant of these two fluxes at any instant of time, it gives a resultant flux, instantaneous static flux. Now, if you carefully see, these two are equal to each other, but they are moving in opposite to each other. So because of this, equal magnitude but moving in opposite direction, so they cancel out each other, and hence your rotor will not experience any torque, because whatever the single phase supply which you are developing, it is having a positive and negative off cycle. So we assume that it is moving in this direction and also in this direction. The fluxes are moving in opposite directions, two halves, one positive, one negative. So what is happening? Yeah, net flux is 0. So your rotor stands still because there is no torque experienced. Whereas in a three-phase AC, we have seen that the three-phase AC supply, it is developing a rotating magnetic field. So the field was moving with respect to space. But whereas in single phase, it is not developing a magnetic field which is rotating in phase. It is developing a magnetic field which is varying with respect to time. And that too, physically if we see, it is not moving. Because we feel that one positive upcycle, it is moving in forward direction, the other one is moving in reverse direction. So what should we do? Unless we do have a field which is moving with respect to space, we can't let the motor to happen. We can't let it to move. So here comes the thing. That's why the single phase induction motors are not self-starting motors. So what should be done to overcome this one? To overcome this one, what they do is that they will try to develop an secondary flux. Okay, so let's get back to the slides. Methods for making single phase induction motor self-starting. Single phase induction motors are not self-starting because the produced stator flux is alternating in nature, and at the starting, the two components of this flux cancel each other, and hence there is no net torque. This is what I said, right? So the solution to this problem is to make the stator flux rotating type rather than an alternating type. Don't think about alternating type. We should make it as a rotating type. In three phase, it is defaultly rotating, but whereas in single phase, it is not rotating. So we should make it rotating such that it moves in one direction. Then an induction motor can become a self-starting motor. So how to make it a self-starting? So for producing these rotating magnetic fields, we require two alternating fluxes such that they can have some phase angle between them. It's not that. See, in three phase, we do have the same three fluxes which differ with 120 degrees phase angle. Now here also, you are supposed to make it a two phase with some phase angle between them. When these two fluxes interact with each other, they will produce a resultant flux. And this resultant flux may be rotating in nature, which may rotate in space in one direction. So once it happens, your motor starts running. So once your motor starts running, then you can remove it. Because once it comes into motion, then automatically your motor starts moving. Okay. So once the motor starts running, the additional flux can be removed so that the motor can continue to run under the influence of main flux only. So your target is you should make your flux to form into a two-phase. So for that, I'll come back to the figure. Yeah. See, this is your main winding. This is your voltage. This was your main winding. Now imagine that this is not there. Whatever the voltage which you are giving, it is a single phase AC supply. As already said, it does not provide any rotating magnetic field. So your rotor will be fixed. For overcoming that one, so what they will be doing is they will be using a starting winding. So now, how many fluxes you do have? Two fluxes you do have. You do have two fluxes. Okay. Now these two fluxes, now if you carefully see, they are placed at 90 degrees apart. This is phi m, which is, I'll assume it as 0. This is secondary winding, starting winding, which is at 90 degrees. Now the resultant flux is a combination of phi m at an angle of 0. Now because of that, there will be a little bit motion. Okay. So because of that motion, your rotor starts moving. Okay. So here I am using this starting winding with the help of a capacitor. So once your rotor attains a speed, then automatically this switch will be opened. This switch will be open. So this connection will cease to exist. Only this connection will be there. So only at the time of starting, you will be using this capacitor for starting winding. Otherwise, you will be having only the main winding. So that's why it is called as a capacitor start induction motor. You call it as capacitor start induction motor because for starting, capacitor is used. This happens most of the times in your ceiling fans at your home. If your capacitor burns out, then your fan will not work. So at that time, you are supposed to move it with your hands till it attains some speed so that it can move up. The old fans used to be, you can see the old fans exhibiting the same phenomenon. Right. So sometimes you will be using capacitor to stay in the course, to stay in the field itself. So it is called as a capacitor start, capacitor run induction motor. So based upon the type of starting, how you are producing your second phase, how you are producing two phase. Single phase induction motors are classified into split phase induction motor, capacitor start induction motor. This we have seen. Capacitor start, capacitor run induction motor. It will be there during the running also. Shaded pole induction motor and permanent speed capacitor motor or a single value capacitor motor. So different types of starting methods are there. You can find them on the internet, go through them, and you can see that these are different types of motors which we use in our daily life. Okay. So coming to the applications point of view, as already said, they are widely used in domestic applications. They are used in fans, blowers, centrifugal pumps, office equipment, everything. These are the least cost machines. They are available in different sizes. They are available for different ratings also. See, they are available for 0.05 HP to 0.5 HP. Very wide range. You can find 1 HP, 2 HP, 3 HP motors also in the markets. Among all this classification which you have seen, capacitor start motors, they are employed where there is a requirement hard to start loads. Where is a difficulty to starting, then you will be using capacitor starters. Just like your compressors, pumps, refrigerators, air conditioning equipment, there you will be using capacitor start motors. Whereas capacitor start and capacitor run motors, they are employed where there is requirement of high starting torque. Just like your conveyors, compressors, pumps, again, but with higher rate. Okay. Whereas shaded pole motors, they are used very small time shaded pole motors. You can see them, very small motors you can be finding in toys. Those are shaded pole motors, a type of single phase induction motors. Whereas this permanent split phase motors, nowadays they are being employed generally when there is a low starting torque requirement, then we will be using permanent split phase motors. Okay. So this is your application orientation of your single phase induction motors. Okay. I hope that now you are able to explain why a single phase induction motor is not self-starting and what are the different methods of self-starting of single phase induction motor and where it is used. So your homework will be try to identify single phase induction motors in your home. How many you are using? Maybe it's a ceiling fan or maybe it's a small toy. Identify how many motors are there in your home. Okay. So these are the theoretical questions. Why single phase induction motors are not just self-starting? How can they be made self-starting? And list the applications. And in the applications, you are supposed to find the applications which are there in your home. Okay. Thank you. In the next class, we will see about DC motors.